Okay, hello everybody. We're going to talk about section 9.3 now. The subject here is equations that we can reduce to quadratic forms. And when we talk about quadratic forms, of course, we know that the quadratic form of an equation, ax squared plus bx plus c equals 0, is the kind of equation that we can generally solve either by factoring or using one of our quadratic forms of formulas, etc. Well, in this particular case, the one thing of note is that the power attached to the very leading term when written in standard form from highest power to lowest power is always twice the second power. There are three terms and the last term is a constant. So that's what we mean right here when we say a times x to the 2n plus b times x to the n plus c. We mean that the very first exponent is exactly twice the value of the exponent for the second term, followed by a constant term. And here's an example of one that is, in fact, a quadratic form. Why? Well, if you look at it, we're actually thinking that the very first term has an exponent of 1, and the second term has a variable, the same variable, with the exponent exactly half of that, minus 4. And so in that regard, we can treat it as a quadratic. Right? When we think about a quadratic, we think about equations that can be rewritten like this. U squared minus 3u minus 4 would be the type of equation in the same form that we could solve. And we know how this one factors. This one factors as u minus 4 and u plus 1 equals 0. And we would proceed to set everything equal to 0. How is this going to work here? Well, in this case, it looks as if all we're really doing is replacing the variable x to the 1/2 with an equivalent statement, in this case, u. So if we keep that substitution in mind, then we can think of this particular equation as being the kind of equation in which, if we factored it, x to the 1/2 power minus 4 times x to the 1/2 power plus 1 would equal 0. And in this case, if we try to set each factor equal to 0, we come up with x to the 1/2 minus 4 equals 0, and x to the 1/2 plus 1 is equal to 0. Well, in the first case, we get x to the 1/2 power is equal to positive 4, and the 1/2 power, remember, is a square root. So this is like saying the square root of x is equal to 4. And to solve this equation, we would square both sides and come up with a solution of the form x is equal to 16. Can we do the same thing with the other one? Well, if we subtracted 1 from both sides, we would get x to the 1/2 is equal to negative 1. And the trouble that we have with that is not that we can't have some number squared, it's that we can't have some number squared equaling a negative number. So there would be no solution to this part of the equation, and so we would stop and we would say that x equals 16 is our only solution. Of course, we should check, and if we check by substitution in the original equation, 16 minus 3 times 16 to the 1/2 power minus 4 should equal 0 if we are correct. Well, 16 minus 3 times 16 to the 1/2 is the square root of 16. That's 4. Minus 4 becomes 16 minus 12 minus 4. And sure enough, 16 minus 12 minus 4 is 0. and so that expression works, and so our solution is x equals 16. Okay, so far so good. So we'll try a couple more examples here in the next video.